Hello, welcome back to algebra. We're going to solve what we call systems of inequalities by graphing. So if you have not watched the last 3 sections on graphing inequalities in 2 dimensions, make sure you've done that because we're just going to be doing a little bit more of that in this section. So here, instead of graphing a single inequality, we're going to be solving a system of inequalities. So just like if you remember back to solving a system of equations, we had 2 equations and 2 unknowns, and we were trying to find, way back before when we had a system of equations, what point is basically the intersection of those 2 lines that would be common to both lines. That's what we call the solution. So we'll have something similar here, and I'll talk a little bit more about it as we go. But the first system that we have is going to look like this. Y greater than 3 and x less than negative 2. So these 2 inequalities, because we have 2 inequalities and 2 variables, we say that it's a system of inequalities. So again, remember, if we were to put an equal sign here and make these equations, how would we solve it? How would we solve a system of equations by graphing? Well, we would graph the first line, we would graph the second line, and if they were just simply equations, not inequalities, these would just be lines here somewhere, and if they cross somewhere, which they're always going to cross unless they're parallel, then we would find the intersection point, and that would be the solution. That's what you get when you have a system of equations. But this is not a system of equations. It's a system of inequalities. So what we have to do is graph the first inequality, including the shading, which we've been doing in the last section, and then we graph the second inequality, including the shading there. And once we get down to that point in the problem, I'll explain how you actually figure out what the solution is and what it means. So for the top one, we're going to graph this. Very simple. You pretend that there's an equal sign, so it's y equals 3, and you should know by now that that's a horizontal line that goes through y is equal to 3, that's y is equal to 3, but because there's no equal sign underneath it, this is going to be a dashed line. So we use solid lines when we have greater than equal to, and we use dashed lines like this when we have no equal sign under it. So this guy is y greater than 3. Now, of course, we've just drawn the actual line. We have to shade it. If y is greater than this line, that means all y values that exist above that. So what I'm going to do is I'm going to shade them like this. And you can do it however you want. I don't really care how you shade it, but you need to draw something up here to indicate that you know that really everything up above here is really included when we graph this inequality. What it basically is saying is that all of the shaded region, every point here, there's an infinity of points up here, not including this line, but everything up here, satisfies y is greater than 3. So that means the y value here, the y value at this point, the y value at this point, the y value at this point, they're all greater than 3. That's all it means. All right, so we're done with that. Now let's go off to the second one. How do you look at this? Well, we pretend that there's an equal sign there. That would be, you should know by now, we've covered this before, a vertical line at x is equal to negative 2. Here's negative 1, here's negative 2, so it's a vertical line that goes up and down like this. There is no equal sign here, so just as before, we do a dotted line to represent that. So let's go up here, and we're going to draw this as a dotted line. And you can label it if you like. You can say, well, let's do it down here. X is less than negative 2. You don't have to label it, but you can. Now, of course, we've just drawn the line. We haven't shaded anything. X is less than this. It means that all points with x values less than this, meaning to the left, is going to satisfy that. So we need to shade it. So this is the dotted line. So that means we're shading everything to the left, including the stuff that we've shaded as part of the other graph. So we're shading this too. Now, it's kind of nice to shade the other direction.